Hello everyone, welcome to the lecture on the topic of laws of logarithm. So we want to come up with formulas. I'm going to be proving some formulas and we'll be using these formulas in future to simplify logarithmic expressions or evaluate any logarithmic expression. So we have log of a product, log of m times n, log of a product of two numbers. I want to show you that it's equal to the sum of the logarithms of those two numbers. Let's say log of, 15, which is 5 times 3, right? 15 can be broken down as 5 times 3. So this could be log of 3 times 5. We want to show that it's equal to log of 3 plus log of 5. That's what we want to show basically. So in order to prove this law of logarithm, which is known as product law of logarithm, because we are finding the logarithm of a product naturally. So we're going to say let x equal to log of m base a, and also let y equals log of n base a. Okay, that's what we are going to assume or let. Now we are going to find m and n using the definitions of logarithm. So I would say m is equal to a to the exponent of x, and n equals a to the exponent of y, because the base is a. So obviously from the definition of logarithm, a raised to the exponent of x should equal to m. These are the exponential forms of the logarithmic forms, in other words. Then I'm going to multiply these two equations, left sides together, right sides together. So I end up with m times n equals a to the x times a to the y. Dot means multiplication. And when you multiply two powers with the same base but different exponents, we simply write down one of the bases and add the exponents, as we have learned in junior grade 9 math course. So basically m times n is equal to a raised to the exponent of x plus y. Okay, and now we are going to take the logarithm of both sides of this equation. We're going to say if two values are equal, then their logarithms are also equal. So we write log of mn equals log of a to the exponent of x plus y. Okay. The base of the log that I select, it happens to be a as well. Okay. So we have log of a raised to the exponent of x plus y, base a, and log of mn, the product, base a. So now we're asking ourselves about this right side logarithm. We're saying, what is that expression? What is that number that when you raise a to the exponent of that number, you end up with a to the exponent of x plus y? So I think the answer is very clear. It is going to be x plus y, because the base a raised to the exponent of x plus y will equal to what we have here, which is a raised to the exponent of x plus y, just using definition of logarithm basically. So imagine, for example, you have log of a to the exponent of x plus y, okay, and the base is a. And imagine this is equal to t. Okay, how would you write the exponential form of this logarithmic expression? You are going to say a to the exponent of t equals this. You're going to say a to the t equals a to the exponent of x plus y. So you see that you have two powers with the same base of a on either side of the equation. So obviously the equality would hold only when the exponents are equal. So t has to be x plus y, which means that this logarithm is equal to x plus y, and that's exactly what I wrote here. So on the left, we write log of mn base a, but then let's not forget what x and y were. X and y were representing log of m and log of n base a. So I can do a back substitution here. I can say log of m base a plus log of n base a equals log of mn base a. So you see that this is what we wanted to prove. Of course, needless to say that the base has to be positive and it's not equal to 1 as always. So this is the proof of the product law of logarithm and give you an example. I can say log of 15, which is log of 5 times 3, equals log of 5 plus log of 3. Any base, arbitrary base you want, you can select. I select common logarithm for simplicity purposes, and I encourage you to grab the calculator right now and punch in log of 3, add it with log of 5, and check to see if it is equal to log of 15 or not. You will tell me later that you got exactly what is explained here. Okay, so I'm going to write this. I'm going to say log of m plus log of n, any arbitrary base a. That is the product law of logarithm I'm including in my chart of formulas. Now I wonder what is going to happen. What is going to happen if instead of m times n, which is the product, I have quotient of two numbers. So instead of m over n, I'm going to change that to m divided by n, or m over n, okay? And I want to show that the logarithm of a quotient is actually equal to the difference of the logarithms. That's what I want to show. Log of m minus log of n. So the product law of logarithm, we said that log of a product equals the sum of the two logarithms of those two numbers. Now, in case of log of a quotient, we're going to say it's going to be equal to the difference of the logarithms of those two numbers. So this is called the quotient law of logarithm. The other one was the product law of logarithm. I'm using the same proof, so it's very similar. So whatever I said before, it's still the same thing, except that instead of multiplying the two equations, this time I'm going to divide them. So m over n on the left-hand side, and here I'm going to divide the left sides. And when you divide two powers with the same base but different exponent, you remember that we used to say we subtract the exponents. So this exponent here becomes x minus y and not x plus y as it was before. And then everything else is the same argument is valid. So m over n, the quotient, log of quotient equals log of a to the exponent of x minus y this time. And log of m over n, I show it with a slash, is going to be x minus y for the same reason I explained earlier. So log of m over n becomes actually the difference of the two logarithms, not the sum. So now that we prove this formula, we can say this is actually log of m minus log of n, and the base could be any arbitrary base a. As an example, I can give you, for example, I can say log of 8 over 2, which is log of 4. It's equal to log of 8 minus log of 2. You can simply grab your calculator, either use the ln button or the common logarithm key, and punch in log of 8 minus log of 2, and check to see if it is equal to log of 4 or not. And later you'll tell me that it is equal actually, and that shows that this quotient law of logarithm is actually valid and correct. Okay, so far we have proved like two formulas, and we had three from before, so 5 laws of logarithm we already know. Another one is like common sense. I want to add it at the bottom, and that is what I just did here. When two numbers are equal, their logarithms are also equal. So I can say if a equals b, this implies that log of a is also equal to log of b, and you can choose any arbitrary base. So I'm going to use lowercase a. And this expression, conditional statement, is biconditional. So from left side you can conclude right side, from right side you can conclude left side. If a equals b, you can say log of a equals log of b. And if log of a equals log of b, sometime in some question, some problem, you can conclude that a must be equal to b. So sort of common sense kind of formula, we may want to add it here. And that's what I did here. I used it actually. I said this left side equals right side, therefore logarithm of left side should equal to logarithm of right side. I use that property, which sort of is common sense. Okay, so now we're going to do more provings. I want to prove another law of logarithm, actually. So let's see what is log of m to the exponent of n equal to the base a. We want to calculate. This is a power. I want to find the logarithm of a power.